Welcome everybody to the first of its kind Axoflow webinar, and we hope there'll be a lot more to come. The purpose today is to try and educate the audience as best we can about some technical issues. With that in mind, I'll just give you a brief overview of the agenda today. Balazs is going to speak on one of our most popular topics. We're going to leave plenty of time at the end for questions and answers, and we'll try to get through all of those today, although we will do a hard stop because we know everyone has work to do, and also we want to make this as concise as possible, and you'll be able to get a recording of it later. So with that in mind, it's my pleasure to introduce Balazs Scheidler, who is the creator of Syslog NG. He's an entrepreneur and investor. He's the founder of Balazs, and he's currently the CEO and founder of Axoflow. Balazs?
Thanks, Neil, for the nice introduction, and I would also like to welcome everyone on the webinar. So today, I'm going to talk about data loss because I find that it affects the production systems in a lot of cases. Data loss in relation to security data that is ingested to our SIEMs, our favorite SIEMs, via Syslog, and I'm going to go into various details how to address and mitigate data loss here, especially when working at scale. As Neil mentioned, we are open to questions. So if you anytime if you have a question on your mind, just be sure to enter it to the chat, and we'll have a few minutes at the end for answering that. Them. Also, the timing is really tight because there is a lot of things I would love to talk about in this session, but I understand that time is of the essence. Some of the topics I will only address at the high level, but I included links and QR codes in the presentation so that you can do some reading after, or obviously you can also ask specific questions now or at a later point, so we can go into those details. And with that, let's get to it. You can say as a quick introduction to myself, like Neil mentioned, I'm Balazs Scheidler, and you can see a timeline of 25 years, a bit more on the screen now, which basically highlights a couple of noteworthy milestones for what I did in the past. Syslog NG was created in 1998, where I was a third-year university student, and I was doing it because I found it fun. Fast forward 25 years, and I'm now the founder and CEO for Axoflow, again working in security data ingestion and feeding security data coming in via various means to our favorite SIEMs. In these 25 years, later is so logging, log management, SIEMs, observability to emerge, and Syslog NG, I'm happy to say, has been an important part of all of these. I also played or took part in the creation of various logging standards by the IETF and others. So RFC 3164, 3195, those kind of things. You can blame me for those as well. The expertise I'm trying to share today is founded basically in these 2.5 decades of time span where I was creating Syslog NG, supporting and deploying it in various settings, from small to large ones as well. And with that, let's get to the presentation, the core part of the presentation. So why Syslog is important? Basically, a lot of data into our security operations centers is required because of our security monitoring processes. So enterprises tend to implement these in order to know what happens and to find incidents, whatever happened in their organization. And a big chunk of the data they collect in these security monitoring processes is coming via the Syslog route. By all estimates, roughly 30 to 50% of the total amount ingested into a SIEM system is coming via Syslog. Why? Because a lot of security systems, firewalls, VPNs, network gear like switches, routers, VPN endpoints, authentication servers will only make their data and their events available via Syslog. And for this reason, Syslog is Even though it's a dated protocol, it started like in the 80s, it still is an important chunk of the data that we collect every day. But Syslog is not without its issues. Normally, our data centers, our applications are created and architected with HTTP-based applications in mind. So we do know how to manage front ends, back ends, databases, load balancers, and everything that makes up a modern application. And the issue is that Syslog is pretty unlike HTTP, which means that most of our patterns, the way we architect those applications, do not play that well with Syslog. We do have a lot of transport options, each with their own quirks, some of them losing more data than others, some of them needing more tuning than others. And that causes a lot of confusion around Syslog data collection. As we implement this kind of data collection throughout our enterprise and get to collecting tens or even hundreds of terabytes of data every day, more and more issues crop up and more issues need to be found and addressed. And the required expertise is far and rare between. So in a lot of cases, Syslog becomes this black box, which only the brave dare to touch, meaning that we don't really have a good visibility to expose these problems and to address them. And basically, the reason Axoflow was founded because of this frustration. I wanted to make sure that these kind of issues are addressed and organizations using Syslog and any other kind of transport mechanisms have a good solution to observe whatever happens in their ingestion pipelines, which basically requires a good observability over the data transports. We also, apart from just collecting data, we also curate the data stream so that it becomes better and more usable whenever it hits the SIEM or whatever backend system we are using for analysis. And obviously, we also help running these systems day in, day out by removing a lot of complexities, by allowing a tailored UI for all of the details that need to be configured in a system like in a distributed system like this. Of course, Syslog is not just, so Axoflow is not just about Syslog. It's a complete pipeline that works with whatever data source you throw at it. So cloud data sources like CloudTrail or CloudWatch, Kubernetes data sources like events there or the Kubernetes log sources, OpenTelemetry, that's also part of the pack. And whatever you have in your data centers, be those network gear or firewalls or traditional Unix or Windows hosts, those are all producing data that you want to collect and eventually make sure that they hit the SIEM in a format that's required on the back end for proper operation of the Security Operations Center. And as mentioned, today's topic is about data loss. Because when we are talking about security monitoring, we are talking about the fact that we try to find incident in our Security Operations Center, and that only works as far as we get the right data into our systems and everything gets there. So data loss is really important to address because as you will see in this example, so let's look at, it's probably not even easily readable, but you can see about 8 lines, FortiGate firewall that it produces that your, ingestion pipeline will probably take care about and deliver it to the SIEM, and you probably will see the outcome of this data in your SOC. Nice charts. It will show whatever IP traffic is coming into your infrastructure, which country, which services, what kind of backends are being addressed. So this is pretty important to collect. But apart from these making into the SIEM and reports and charts being generated, you might find that something is missing from this picture. And I would not go into reading all those tiny letters, but maybe this is missing. So this is a specific message from the same firewall, but the previous ones were just normal traffic lines that where the firewall is telling the backend systems that one connection went through. This one is actually about a security incident. The same firewall, it's just a different context. And as you can see, maybe not all of the messages are of the same importance. Some of them are more important because this would be, as a remote code execution issue, this would probably turn into an actual incident that you need to address as soon as possible. The previous traffic lines, they will probably be just used for reporting or a long-term trend analysis where the completeness is not necessarily required. My point being is that once you do have data loss, you may have lose these important lines whereas you collect everything else. And you really have to make sure that the important ones are also collected. The problem is with the way we usually run these ingestion pipelines is that they don't really expose detailed metrics and detailed information about what is being lost. When you go to the SIEM and you search for whatever application you want to look into, maybe this FortiGate firewall that I just mentioned, it will never tell you that, they will tell you that they collected, I don't know, 10 terabytes of data from this specific application that specific day, but they will not tell you what was being lost. And maybe that's just a tiny fraction, but still the more important ones could be part of the tiny fraction, which means that you're missing an important event to respond to. So Syslog is losing data, and probably I'm not surprising everyone on this webinar. So that happens. What is puzzling about it is its amount. Just a couple of weeks ago, we deployed Axoflow at a customer, and just after the metric acquisition and the monitoring started, within 10-15 minutes, we started getting alerts on data loss. This specific application wasn't losing that much. They lost roughly 100,000 messages every day, and compared to the total amount, which was billions of messages, this doesn't seem much. But as long as data loss is there, you may not have control what part of it is lost. So that's the surprising fact. And I have seen production cases where they were losing 20% of the Syslog ingestion pipeline, which is a lot. So what's the learning here? What would the story be if we had visibility into all of the logs and not just the ones that we collect? And the answer is that we don't know a means to know it, as long as we are not ensuring that data is not lost. So we have a leaky pipe. We have a pipeline starting with the firewall, sending data to their neighboring Syslog server. Some agents start picking it up, sending it to the SIEM, whatever. So there are multi-stage ingestion pipelines in our infrastructure to implement this security monitoring process. And often we call these infrastructures pipelines. And this pipeline is leaking, just like plumbing under our house. How to fix the leaky pipe is basically just two things, not always so simple things. We need to make sure that we are over-provisioning our logging infrastructure, give it whatever resources it needs and maybe a bit more, and then also do some tuning so that the system actually uses those resources. I've seen more often than not that people allocate a lot of CPU, memory, disk, whatever, to these kind of systems, but they don't know how to set it up, and at the end, it just doesn't use all the resources that are available. Those go hand in hand, so provisioning and over-provisioning and tuning. Why do we need to over-provision? It's simple. The logging system needs to absorb anything you throw at it, and in a moment I will describe why. But provisioning resources and tuning so that it's actually used is just one part of the solution. Second part is equally important, monitoring and alerting. As I mentioned this with this customer, they didn't know they were losing logs. They were doing some tuning, and they believed that it was right. And at the end, it wasn't. So as long as you're not actually doing the monitoring and alerting on data loss related issues, you will not know if your tuning or resources were adequate or not. And of course, this is a continuous process. As load increases, as you add more resources, as volume goes up, you need to always consider if that was enough or not. So why is a logging system losing data? We have all these nice IT infrastructures collecting and delivering data from one place to the other, and they don't. So why is logging different? And to understand why, I created this metaphor where I used a buffer tank, which is basically just a big chunk of water stored in a tank. And of course, water is coming in via pipe and water is going out to wherever it needs to go. And within the tank, we have some water levels, which basically represents the data that we store in a specific buffer. Of course, if we consider this buffer tank example, what should happen if the incoming water, so if we have more incoming water than the water going out, this of course means that the water level goes up, right? Once our backend systems clear up and we can send out more on the output side or the egress side, that means that the water level decreases and eventually the buffer itself empties. So these kind of buffers are everywhere in a logging system. And the question is, what should happen if the tank itself becomes full? There are two basic answers to that question. One, when the buffer becomes full, you can just drop the excess. That's the overflow on the right-hand side of this buffer tank with the exclamation mark on it. If you drop the excess, then everything stays healthy. Data comes in, data goes out. We just drop some data on the floor. So that's one answer. The second answer would be, no, we don't have the overflow mechanism. We will just try to take in everything, send out everything, and do everything in our power to make sure these are balanced out. But eventually, that's the nature of life. If more water is coming in than going out, then eventually it gets full. So we would need to propagate the back pressure back to the source. So what should happen if an application is trying to send a log message and the log infrastructure is unable to process it? One way to do that is simple. You just stop the application from producing log messages. That's easier said than done. What should happen with an application that is unable to produce messages? Well, we can stop it, right? In my experience, stopping production applications completely until log resources become available is not really a preferred behavior. People tend to like their production applications work. So therefore, logging applications, even if they are in overflow mode, are unable to stop their sources. So this means that this is why we need to over provision them. And this is why we need to take anything that we get and absorb and provide the necessary resources and make sure that we can actually work through them so that the data gets to the end. And so anyway, an overflow valve is still part of the picture. 99.9% of logging pipelines are implemented with this overflow mechanism in place. With the buffering abstraction explained, let me show you this more specific example of buffering. This displays one specific log server and how a log server would receive messages from firewalls like FortiGate I mentioned earlier. This is basically 3 sets of buffers in the same computer, basically. From the right-hand side, let's start there. That's where a log server application would run. It has its own buffers. It takes in data and it sends it to the backend, maybe Splunk, maybe Dynatrace, maybe something else or a Kafka topic, whatever. It does have some buffer implemented on that section of the pipeline. There is a middle buffer here as well, which is implemented by our operating system kernel, which is called the socket buffer. Again, the same principle. It's not disk-based, so it's not persistent, but it is a buffer where UDP packets or Syslog packets arrive and which are taken out by the Syslog server on the right-hand side. So that's the one in the middle. But we also have a third one, which is rarely an issue, but I displayed that for completeness sake, which is a buffer in our network interface card where there is a packet buffer where the NIC itself receives packets and the kernel needs to process it. So we can see that in normal operation, all of these 3 buffers will need to work so without overflow. Whenever there is overflow, we will have data loss. In most cases, and that's why I highlighted this specific issue, even though buffering is a more general problem, the issue is usually the kernel buffer in the middle. I mentioned that most of our patterns and behaviors or how we architect solutions in our data centers are HTTP centric. That applies here as well. the kernel defaults for the socket buffer is so low that you will almost always have data loss if that's not properly sized. I do have a link to a detailed article on our blog site where you can read how to tune that. But my point here being is that sometimes buffering, even though it was simple with water levels in the metaphor I was introducing to you, but it's usually a series of buffers that each need to work in concert so that you can get away without data loss. But it's not just these three specific buffers that are here. I mean, sometimes it's just a set of files on disk. Sometimes it's a Kafka topic. Sometimes it's, some kind of internal queue, even undocumented somewhere. So when someone is considering data loss, we need to understand where buffering is happening and try to adjust their parameters if that's possible. Sometimes it's not. This part of the presentation is some general tips on how to do sizing. I try to use examples to show you edge cases where you need to pay attention. But this part, I couldn't go into all of the details I wanted to. So these are some high level recommendations with pointers to blog articles that you can read later. So the first one is tuning the buffer capacity. Which applies to the, how much data we can store in a specific buffer. Usually, we need space for two reasons. One, maybe our backend system, maybe our SIEM can go down for a day or hours or minutes. We may know how much we can expect of its availability. So that's one aspect. The second aspect is that water flowing in and going out is never a balanced process. So sometimes more data is coming in and less data is going out, and then the other side happens. So this is very volatile. And sometimes when we do have a peak in our ingest or in our ingress, we cannot send everything to the egress. So this means the water level is going up. The second part of the estimation how buffer tuning needs to happen is that we have to know how much time our backend system needs to recover from the peaks. Sometimes this is just seconds or even a few minutes. Sometimes in aggressive scenarios, we can overload a backend system so that it takes in backlog is building up the entire day, and then it recovers during the night. And then the next day again. It creates backlog because it cannot process everything coming in, and then during the night it recovers. It's easy to see that if the recovery is not there, so the night it cannot recover, we basically do not have enough resources or our tuning was inadequate because eventually we will lose data for sure. So these are the two parts we need to consider when trying to tune our buffer capacities. Of course, once we know how much time it can be out and how much time we need for recovery, we can easily calculate the amount of data that we need to store in our buffers, which is basically the amount of time times the rate. I include a couple of examples here. I'm not going into details on those, but you will have the slide. So this is what I just explained. Daytime, overload, nighttime, recovery. The next part, we have a buffer size, we size it properly. The next part is about tuning how ingress is made. That does have a couple of knobs as well. And it can be responsible for various data drops as well. I mean, the ingress path into a buffer, that's network connectivity. Maybe our bandwidth of the network link is not enough. So that can also affect how much data we can take in. There are transport protocol issues. Sometimes some of these transports that we use in Syslog infrastructures can be more lossy than others. We might need to change the kernel receive path. We might need to change the Syslog receive path / parsing. A couple of ideas are here with QR codes so that you can open them via links. Again, unfortunately, I don't have enough time to go into this, but enough detail is available on those blog posts. Again, also, I mean, imagine we have the buffer size, we do have ingress. The egress can also be tuned. Again, here, sometimes we don't have enough connectivity. Sometimes data formatting is very expensive and CPU becomes a bottleneck. So we need to make sure that it doesn't And again, various transport protocol issues can come up and again cause data loss. So I basically covered all the issues that can relate to data loss. I tried to give you helpful pointers into how to tune them in general, and in blog posts, very specific details in how to overcome those. But what I also mentioned is that tuning and over provisioning is just one side of the problem, because even if you do everything and properly tune your ingestion pipeline and there is no data loss, volume goes up and you need to make sure that it doesn't ruin the picture. So monitoring is really important for these kind of systems to avoid losing data. And monitoring in general, like what is implemented in something like Prometheus or Zabbix or whatever application monitoring solution you are using, is not really pipeline specific. They lack the required metrics that you need to monitor in order to diagnose these kind of issues. I listed a couple here. I only covered the first one. Message delays, how much time a message spends in the pipeline before it can be delivered is a key metric for understanding overload and resolving them. Of course, buffer fill levels, message drops in the various buffers, these kind of things are all important to find out the root causes. Yeah, of course, I think I could introduce you to the issue of data loss and how and what is causing it and why it's still a problem. And I do consider that the solution here is the combination of a tailored solution for managing ingestion pipelines, and Axoflow is such a solution. It's a pipeline itself, and it's also a management infrastructure for these kind of pipelines, even those that are already in place. So it's not necessarily a brand new or net new deployment. But the various components that we haven't on show for you is the console itself. The Axoflow console is about an automated management of logging infrastructures. Again, stressing that if you have something in place already that can augment the existing solution, it takes care of observability of the pipeline itself. It does monitoring the specific metrics I mentioned, visualizing that and alerting on the important ones. But apart from monitoring and visualization, it also gives you insights into the data flows as they happen in real time, so that you have a better understanding what kind of data you're collecting at the end. Exo Router, that's our data plane solutions. That's where we put in all the goodies for how we think data should be collected, security data should be collected. So it's not just taking data from A to B, but also an automatic classification and curation infrastructure to make sure that data is getting to the SIEM in the format that's easiest to use and that helps the security analyst to actually make use of it the best way possible. Also, it implements Syslog collection with carrier-grade devices in mind, like tens or hundreds of thousands of messages a second kind. And of course, Axoflow is also about expertise. I already mentioned that we've been in this space for over 2 decades, so we do know how to fix data loss and other issues affecting logging pipelines. So I mentioned OS tuning and as a method for managing data loss. Did you have any specific posts or links that would teach more about this? Absolutely. There were at least 2 or 3 different posts. All of them were linked from the presentation via QR codes. And that has specific instructions to tune UDP and also to monitor TCP-based Syslog, because that's a lesser known fact that TCP can be lossy as well.
Yeah, and I'll just add to that. If you didn't get the QR code, you will get a copy of everyone will receive an email with a link to this presentation, the recording, or you can just reach out to me or Balazs directly, and I'll make sure you get what you need.
Also, just one more thought is that we do have a white paper about the metrics we are using and how easy it is to deploy them. And also a recent publication where Syslog architectures are discussed, how to architect these in a way that works best from the data loss perspective and also the collection perspective. Next one. Is there an air gap solution, no access to the internet? How Axoflow is architected is that the data plane operates on the customer premises, just like Syslog data is coming from a firewall usually, or a VPN device, or whatever, or a router, which is usually on the customer premises. So everything we do works there, so that it can collect and route data wherever it needs to go. Axoflow is available, the management piece, so monitoring and metrics and alerting and those kind of things, those are primarily SaaS-based, but it can also be available on-prem. We prefer the SaaS-based simply because it's much easier to deploy, and that's how we start our POCs, but we are open to discussion for air gapped solutions, if that makes sense. As you can see, how do you tackle HA issues, especially UDP scenarios? Scaling out is one thing, but when you have a single receiver, you just have an SPO. Yes, the HA is difficult because of how Syslog works. There are ways to distribute one specific UDP stream of packets into various receivers, so not just one, so that it's not strictly SPOF, but in order to load balance it out to multiple nodes, what requires a special load balancer that distributes the load on a per message basis. But the real solution here, and that's what we are using for long haul or long distance transfer, is to use a different protocol. So Syslog is great for collecting data locally, but not necessarily as great for delivering data long-term over a WAN link. And in those cases, we standardize on OTLP, which is a pretty modern protocol for transporting log messages. This is the Open Telemetry Transport Protocol. And we just transparently map the incoming syslog data over WAN links. And that works nicely with AJ. I mentioned Access Syslog. In the timeline, you could see that project, which basically started as a Access Syslog is a fork of Syslog-ng, which started as a container image, and that was the original goal of the project, to create a cloud-native deployment package for Syslog-ng. But eventually, it became a fork, and since that time, the project itself also provides RPM and dev packages on everything that Syslog-ng provides. So yes, it's a drop-in replacement. One more. How do we measure any loss? Any loss is wrong. And like I mentioned, we tend to talk about terabytes or gigabytes of data ingest daily. And it doesn't apply that well to log streams because we have messages lost, not bytes. And basically, that's how we measure it. And that's how we show it in various charts where data loss occurs. And whenever this happens, the next step is to make sure we have enough resources and we tune our stuff so that it's actually being used. Axoflow helps by automating this and also providing auto scaling, which is pretty difficult to create without automation and without these kind of metrics in place. Okay, next one. Mentioned OTLP. OTL is going to replace Syslog. Not for Syslog, even with its issues, is not easy to replace. Just imagine all the deployed devices and appliances that only implement Syslog. So as long as we want our checkpoint, Palo Alto, FortiGate, Cisco, whatever device to continue to generate logs, Syslog will need to be supported. And even though there were tries and attempts to replace the Syslog protocol in these settings, those were all unsuccessful. So OTLP and Syslog will coexist for different parts of the pipeline. That's my answer. And I think we did tick all the questions.
Yeah, are there any other questions out there before we close? Certainly appreciate all your questions. We'll have one question for you all at the end, simple poll, if you wouldn't mind answering it, and any suggestions you might have about any topics you might want us to cover in the future, please drop those into the chat or send us an email as well. You can see that now in the chat. Again, if there's any handouts you want to get or documentation you weren't able to grab during the presentation, let us know. And you will, as a reminder, be receiving a link to a copy of the recording. And with that, I'll just check one more time. Looks like that's it on the questions. I want to thank everybody for joining, and we hope to see you again on the next one. Thanks again, Balazs, and we'll speak to you all soon.
Yeah. Thank you. Thanks for everyone
Yes.
for attending.